and hate speech detection by Matthew Purver from Queen Mary University of London and Marko Pranjić from Trikoder, a Croatian media company. Please, Matt and Marko.
All right, so yes, I'm Matt Purver from Queen Mary, and my co-presenter Marko Pranjić from Trikoder. I will hand over to Marko to start things off.
Hi everyone, just to start with an explanation that one important improvement of the online news portals over the older printed newspapers is a vibrant comment section below the news articles. Those comments are creating online communities. People see this small area of text almost as their own personal space. From there, they engage other readers and journalists in the discussions, provide corrections and missing details to the news story, and open up new venues for the future news articles. Well, that's the ideal case. But this sense of ownership also leads to communication patterns that are better prevented before they escalate. Toxic comments, hate speech, slander. Publishers have a responsibility to defend those personal spaces and make them safe for expressing opinions. Here is an example of a news article with a topic that sparked a discussion with some comments that are not appropriate, and moderators on the site have reacted and blocked some of those. It is okay, and we do want that readers express their opinions, but some limits should be drawn. Use case of comment moderation here in the project was applied to a user story from 24 Sata. 24 Sata is a tabloid from Croatia and one of the biggest news publishers in Croatia. They have many of the same problems as illustrated on the previous slide. This user story from 24 Sata is seen through the lenses of the fictional person that works as a moderator for comments below the articles. Let's call him Branko. Branko is faced with an almost impossible task. There are on average day almost 8,000 comments spread over several hundred articles. In peak hours, there are 1,000 comments per hour, or when some big article lands, it can become chaos in a short time. 5 to 10% must be blocked to prevent them appearing online. This is all currently done manually. There are some helps that they implemented, for example, keywords lists that tag some of the comments so he can focus on them first. But those keywords lists are not the answer. They go out of the date very quickly and people adapt to them. So we need some better way to handle it. Solution from the EMBEDDIA is to have an automated real-time classifier to spot problematic comments before they appear online. We use cross-lingual training from well-resourced languages to give performance even with limited data.
So I'm going to explain a little bit that last statement of Marko's that we talked about, the fact that we use cross-lingual training. I'm going to try and explain a little bit why we need to do that and the benefits that it gives us. So in this kind of strand of our work, our basic aim is to build an AI tool that will, based on the text of a comment, detect which comments need to be moderated and which can be left alone. Ideally, if we can do this reasonably accurately, or at least if we can find the ones that are most urgently in need of moderation accurately and quickly, then we can show those outputs to people like Branko and they can use it to speed up their work. But this is quite a difficult thing to do for many reasons. One is that the output of a tool like this would really need to be different for different users, for different newspaper publishers in different contexts. The decisions of moderators need to be done according to a particular policy and justified according to that policy, and that'll be different for different newspapers, different for different publishers, different for different situations. This picture shows us an example of some of the moderation rules that 24 Sata, Branko's newspaper, use. And you can see that there are lots of different reasons for that comments might need moderating, varying from hate speech and abuse to things like advertising on the content or using particular illegal content, using different languages even. So these will be very different in different situations. That means that one tool isn't going to work for everyone. We can also think about the input as being very variable. So the language that people use will be very variable in different situations. It's quite unpredictable. Users are actually, it turns out, quite good at learning how to guess what moderators might do given particular words or phrases and change their behavior accordingly. So the language might even change over time, and our tool would need to adapt to that. So that means that any tool we build is going to need to adapt to give different output in different situations, to supply different output information, but also is going to have to be able to adapt to different situations and make decisions that might even be different in different contexts and that might change over time. And overall, that means we can't just build one fixed tool. Any tool like this will need to learn from real behavior of human moderators. It will need to learn from real data of real users commenting and be then able to learn quickly in situ to do the job that we need. The standard approach that we've been using is one that's very common in natural language processing, which is to treat then this task as what we call a supervised task. That means we teach the tool from data examples that we give it. Generally, we have this kind of idea where we have a tool which knows something about language. It has a language model that knows something about English, or in this case, Croatian. And then we teach it, given some accurately labeled data in the right language and in the right kind of text genre, to learn how to make a particular decision, in this case, the block or don't block decision. Given a good enough model, this can work really very, very well. We find that the accuracies can get up towards human accuracies, high 70 or 80%. 100% is never going to be achievable, of course, and these things can be subjective anyway. So we find that performance can be excellent as long as we've given it enough suitable target data to train on. However, these kind of methods give us a real problem when we don't have enough data. You'll see from this plot of how the performance of a similar classifier changes given the amount of input data we're able to give it to teach it. And you'll see that the performance is much, much lower when the amount of data available is lower. And of course, this is often the case when you've just started to use a tool, or when it's been given to a new news publisher, or when you have a new setting for your tool. So what we've been spending a lot of our effort on is trying to solve that problem. Rather than just using a single tool that's trained on a single kind of data, in this case, data in Croatian from the 24 Sata paper, we use what's called transfer learning, and in this case, cross-lingual transfer learning, the methods that we've been developing on the EMBEDDIA project. Here, what we can do is we can pre-train the language model that we're going to use using some other data labeled and available for a similar task. But it can even be in a different language. In this case, we've been trying to train our classifiers using language in English and in German and in a variety of other languages from different newspapers, then use that model to transfer to get our Croatian model and the 24 Sata data started much quicker. And what we find is that this improves the accuracy of our classifier across the board by measurable, if not astronomical amounts. You'll see on the right-hand side of this graph, the improvement is noticeable. But where it's really, really impressive is that on the left-hand side of this graph, where you have little or no data in your new language, in this case in Croatian, or your new setting, 24 Sata, you can still get really good performance. The red line is the performance that we get with our cross-lingual transfer methods. Even in this case, we can see that the performance we get with no training data at all, right on the left-hand side of the graph, is essentially very, very similar to what we would get just training on a whole lot of Croatian data. So this way we can create tools that you can put into place very quickly, very easily, with no training data necessary and no experience necessary, and get them started very quickly, and they will then learn to improve as they get more data. Back over to you, Marko.
Thank you. What I'm thinking, and probably some of you also do, all those scientific results look exciting, but how can we use them in a real newsroom? Well, we got you covered. Our results are prepared to be used, and we invite you to check them. I will now mention some 3 ways to try it out. One is GitHub repo with with a pre-trained model and the API. This is packaged in a Docker, so it should not be a challenge to try it out. The second is also a repo with tools to train and test those models on your own data. For example, if you want to adapt them more specifically to some of your use cases. And and the third way how you can use all those models is through the text toolkit. This is a tool that will be introduced later today, and we invite you to try them out and send us your success stories.
So Silva will be giving us a full explanation of the EMBEDDIA Media Assistant, the toolkit that we've been building through the project that showcases some of the practically usable tools as well as the more basic methods. I think after the next couple of talks, we'll give you the link to that website so that you can go and have a look and use the live demo yourself with examples that you might want to test. Right now, we'll just show you a couple of examples in a couple of interesting and challenging languages to show you the basic idea of how it works. So first, I'll stop sharing this slide if I can. Yes. And move back over to the demo page. I hope you can see that. I'm now going to show you what happens with a couple of examples in the Croatian language. And I'll show you the output of the cross-lingually transferred model, the best model that we currently have for our Croatian language comments. And I'm going to ask Marko to read out the examples if he wants to and explain them, because his Croatian, as you will probably have guessed, is significantly better than mine.
Yeah.
Example number one.
Thank you for this this opportunity to say those things. Yeah, so just to translate it to English, this text is means this journalist is gay that writes propaganda for government. So this is obviously a comment that is offensive, that should be blocked and does not contribute to any discussion.
I can show you another example to give Marko some more fun reading out rude things in public.
Yeah, thank you. Those cretins like you should need to learn how to communicate with people. Yeah, it sounds slightly less offensive in Croatian, but it's still the limit is drawn so that this kind of comments are not something that should be encouraged nor shown on the website. And once you have some of those comments on the website, people flock. They just bite on it, and the whole discussion goes towards offensive talk.
Another very short and simple example, which I know Marko is going to enjoy, which I'm just going to use to show you the difference between our model that we prepared using this cross-lingual initialization to really try and optimize its performance, and the simpler model that I showed you on the first graph in the talk that's been trained on suitable data, but doesn't have a model that is as well tuned for this problem. And I hope we'll see that one of them gets it right and the other one gets it wrong. Marko will explain whether it's offensive or not.
Well, this is a very interesting example because this comment is almost a basic one. It's just, one fuck you. And it appears that, some tools don't even catch those. So this is a win for this EMBEDDIA's model that, you know, it works as you expect it to work even on those examples.
And just another illustration then of the cross-lingual nature of this and the fact that we can initialize these tools well to be prepared to a reasonable degree of accuracy, even for language that they haven't seen. Here's an example that Carl Gustav sent me earlier, which I don't understand because it's in Swedish. And we're going to pass it to our cross-lingual model that was initialized by training on English and I think some German, or this one, actually one of them was English and German and one of them was just English, but I promise you that none of them have ever seen Swedish before. Now it tells me that's offensive. Carl Gustav, I wonder if you can confirm that's true and maybe explain what it says. You're muted at the moment. Oh, you're still muted.
It's a joy just to do that. When all those brainwashed idiots understand that they are getting fucked, sorry for that. Everything is about money and the human being can do nothing but the climate.
Representative of the kind of things we do actually see, of course. And just to sort of confirm that this one I hope is a neutral example that you sent me before. The classifier is telling me that it's okay and doesn't need moderation. Just to kind of show you that it's not just that our classifier always decides that Swedish is offensive. I wonder if you can give us a quick paraphrase of this one, Carl Gustav.
Yes, I talked about and read Finnish magazines and books. The grammar I heard without learning it, and I wrote the highest marks in Finnish language in school.
So perfectly reasonable. All right, thanks very much. That's it from us.